I'm Mohammed Amalali. This is a video presentation for the coursework for artificial intelligence. So first we imported the MDB dataset with the code the values so we can see the dataset. Then we choose the 500 most used words to consider for the training purposes. We can see the list of these 500 words. Then we start building the models. The first model is the CNN model. We implement 500 as the maximum number of words with a length of 128 characters. And we include a couple of layers with one embedding layer, command layer, and then layer. So we can then train the models. We used to meet to epoch for this presentation in order to implement it in less time. So we can see here the accuracy, the loss, and the values. Then we can plot those values here. We can do the same for the LSTM model. In a similar way, we use 500 words and 128 character lengths. We run the model, we train it, and we store it for later purposes. We can do some predictions and we plot our values. We can see here the accuracy, it's around 82%. We can also submit some predictions. We can see that in some cases, most of the cases, at least for this example, all the cases are right. Then we implement GRU model in a similar way, using the same parameters for the max word, the max length, with a different layer, in this case the GRU layer from Keras. We can implement as well all accuracy metrics, in this case 81%, and we do some prediction. For the BERT model, we operate in a similar way. In this case, we must use tokenizer to tokenize the values. Then we have to convert integer to text in order to be able to read it by our model. We create the string text and X text, and we use tokenizing and padding in order to fit our requirements of the BERT model. We use the TF-BERT sequence classification from pre-trained provided by the transformers library, so we can run our BERT model. We can see the result. We store the BERT model for later purposes, and we can print our results. In terms of accuracy, we can see that this model has achieved a very short accuracy of 50%. It may require more parameterization, more customization. The next step is to print some predictions. As we can see, we can see here some examples, and here we can have some meta ensemble techniques. First of all, we use the plugin for CNN and for LSTM models. We can see that it basically splits the input in 10 parts, so you can implement some bagging techniques. In this case, we can find that the value is 82% of the accuracy. Then we can implement some stacking. This allows us to combine the predictions from different models. In this case, we are using the trained CNN, the LSTM, and the trained GRU. And we can see that the accuracy of this combined stacking model is 83%. And we can implement boosting as well. In this case, we can use boosting for the different models on each one on its own, and we can see that the values it's quite small for these values, 55% for each one of the models. In this case, when using the decision tree classifier as a base estimator. Thank you.